is very different than chapter 2 from the perspective of, well, we're not going to be dealing with a whole lot of numbers and calculations, right? So that may be a good thing for some of you, maybe a bad thing for the remainder of you. But it's very, very descriptive in terms of what we're going to be looking at. And specifically what we're going to be focusing on here is one of the parts to the definition of chemistry that we talked about way back at the beginning of the class. Right, so if you remember, when we defined chemistry, we said that chemistry was what? Anybody remember?
Study of matter.
Study of matter, the changes that matter undergoes, and the energy associated with those changes. Right. So now we're going to take a brief look at each of those three facets of our definition of chemistry. We'll talk a little bit about matter, some of the changes, and then a little bit about the energy. So the first thing we're going to take a look at is how we can actually classify matter. Right, and if you also remember, we defined matter back in week 1. We said that matter could be described as what? Stuff. Okay. Correct. Can you give me a little more technical definition of matter? Anything that occupies space and has mass, right? So there are two parts to it. So anything that has mass and occupies space or volume. Right, and we looked at, back when we defined it, different examples of matter, and that could be pretty much anything, right? Most things we can think of. So the pen that you're holding right now, your chair, maybe you, right? You're made up of stuff and you occupy space. So there are lots and lots and lots of examples. Just put ... of matter. So based on our definition of what matter is, we can classify it on a couple different levels. And the first way we're going to classify it is based on its composition, or what it is actually made up of. Right? And we're going to first of all take a look at two broad categories of matter. We're going to have pure substances, and then we're also going to have mixtures. Right, so that's going to be our first sort of separation in terms of how we define, how we distinguish different types of matter from each other. So, matter can be either a pure substance or it can be a mixture. What's the difference between these two categories? Well, a pure substance, first of all, can be described as something, a type of matter that has a composition in terms of what it's made up of. It's always fixed, it's unchanging. The term that we give to that is definite. Right? So a pure substance is a type of matter that has a fixed or definite composition. And pure substances themselves can be further subcategorized or subdivided into two. They can be either elements or they can be compounds. Right, so matter can be either a pure substance or a mixture. A pure substance is an example of matter that's made up of a fixed or definite composition, and under that umbrella we have two subcategories. That pure substance can either be an element or it can be a compound. So what's the difference between the element now and a compound? Well, an element would be an example of a pure substance that is made up of only one type of atom. Right? We haven't talked about the word atom yet, but this is the basic building block of everything around us. So for example, an example of an element made up of only one type of atom would be aluminum, right? So if you have a sample of aluminum, an aluminum can, or aluminum foil, for instance, right? That is an example of an element. It is made up only of aluminum atoms. Right? Similarly, you can think of if you have a copper pipe or a copper wire, right? That would be an example of an element because it would be made up of what type of atoms? It would be made up of copper atoms. Right? That's the only thing that makes up that that element. Right, so your elements are pure substances made up of only one type of atom, and that's different than a compound. Right, a compound is still an example of a pure substance, but in this case, it's made up of more than one different elements in a fixed or definite ratio. So an example of this would be water, right? So water itself, it's a pretty common substance, and it's a pure substance. If you just have water in something, if you just have a sample of water, it's made up of two hydrogen atoms and one oxygen atom, right? And if you probably, or you may or may not know this, but the chemical formula for water is H subscript 2 and then O. And that actually tells you what the ratio of those two things are. So we have two H's to one oxygen. And that's always going to be the makeup of water. If you change that ratio, it's not water anymore. But if you change that ratio to maybe two H's to two O's, it ends up being something called hydrogen peroxide, H2O2, which is very different than water, as you probably know, right? When you get thirsty, you drink a bunch of water. You don't drink hydrogen peroxide to quench your thirst. Right? That would be counterproductive to quenching your thirst. Can you think of another example of a compound? Hydrogen peroxide, yes. What was that? CO2. And what's the name of CO2? Do you know what that is? Who said CO2? Somebody said CO2. Carbon dioxide. That's what you're breathing out right now. Right, so it's made up of two different elements, carbon and oxygen, in a fixed ratio. So in this case, CO2 has one carbon and two oxygens, always in that ratio. So it is a pure substance, right? It's made up of, its composition is fixed, but it would be a compound because it's made up of different elements in that fixed ratio, your elements are made up of the same atom, only one type of atom, right? So the aluminum or copper, and then I'll just give you another example. Oxygen that you're breathing in right now would be an example of an element. This is made up of oxygen atoms. All right, so those are your two categories of pure substances, elements or compounds. The second main category of matter compared to pure substances is your mixtures. Right, and what a mixture is where you have more than one pure substance that share the same physical space but are not chemically combined. Right, so we have two or more pure substances that are just around each other. They're not chemically linked together. And the other characteristic of a mixture that's different than a pure substance is it's relatively easy to separate the components. So we can say the components of the mixture can be separated by, I'm going to say, normal physical means. All right, so some examples here of mixtures. So up on the upper right side there, you can see some pasta, for instance, in a pot. So if you make, spaghetti and meatballs, for instance, that will be an example of a mixture. You have the spaghetti, you have the meatballs, you have sauce. All of those just share the same physical space, but they're not chemically combined. And you can obviously separate them from each other, right? You can separate the meatballs from the spaghetti. Another example here would be if you had something like sand and salt. Right, so the sand and salt they're two separate things, they're two pure substances. They're not chemically combined if you put them together, but you can separate them from each other. Right, you don't have to do anything complicated to actually separate them. So mixtures themselves, which are just instances where you have more than one pure substance that share the same physical space, can be subdivided into homogeneous mixtures and heterogeneous mixtures. And the difference between these two has to do with how evenly dispersed or how evenly distributed the components of the mixtures are. Right, so in a homogeneous mixture, we can say that the components of it are uniformly distributed. In other words, it's going to look the same throughout. So an example here for homogeneous mixture would be something like the brass, where you have a combination of two different elements, copper and zinc, right, that are not chemically combined, but they just share the same physical space, right? And if you look at a brass thing, you know, a brass instrument, a brass bell, a brass furnishing. Right? Can you tell where the copper ends and the zinc begins? So try that if you have a brass fixture at home. Right? It'll be impossible to do that, right? Because it looks the same throughout. It looks uniform throughout. Another example of a homogeneous mixture would be if you take some water, so water is H2O, and you add a little bit of salt to it. So a pinch of salt. So you add some salt to this, you stir it up, and you dissolve the salt in the water. Right? When you look at that sample of salty water, the top part of it will look the same as the bottom part. So the salt here gets evenly dispersed or evenly distributed throughout the entire sample itself. So that would be an example of a homogeneous mixture, and that's different than a heterogeneous one in which the components are not evenly dispersed. So it does not look the same. All right, and as an example here, we have a glass of water, and then we have some copper in it, right? So if you put some copper in there, the copper does not get evenly dispersed throughout that entire sample. The top half of it would have way more water than the bottom half of it, where the copper is. So the distribution of the components is not the same throughout the entire sample. Right? Maybe a better example, depending on if you're hungry or not. So let's say that's a pizza. All right, and let's say that's a pepperoni pizza. So we're going to draw the pepperonis in, like so. So first of all, would this be an example of a pure substance or a mixture, the pizza? It's a mixture. And then is it a homogeneous or a heterogeneous mixture? Are the components evenly distributed throughout the sample? No. Right? So for instance, if I take this slice of the pizza here, I have 2 slices of pepperoni. If I take this slice, I have 1 and a little bit. Right? So the pepperoni in this case is not evenly distributed throughout the entire sample. So that would be an example of a heterogeneous mixture, right? So you have several substances in there that just share the same physical space, and they're not evenly dispersed throughout the entire sample. All right, let's take a look at a couple other examples. Let's start down here. Let's start with D. Pure substance or a mixture? The air that you're breathing in right now, is it made up of just one?
No.
Mixture.
It's a mixture. What about helium? Helium, you know, in your balloon, if you have a helium balloon, it's only made up of helium atoms, so that would be a pure substance. What about aluminum foil? That would be pure as well, right? If it's called aluminum foil, one would assume that it's made out of aluminum. Yes.
I have a question. Does that include the oxide layer on the aluminum foil, or is that something that we add separately?
So this is assuming the aluminum foil is just
Okay.
brand new, it's shiny,
Don't put water on it.
right? Yeah. And then the pasta and tomato sauce would be an example of a mixture, right? You have several different substances, or 2 different substances that share the same physical space. All right. Homogeneous or heterogeneous? hot fudge sundae. Ice cream with some syrup on it. Heterogeneous, right? The syrup is not evenly distributed. Shampoo, baby or otherwise. That would be homogeneous, right? And if you don't know when you go home, take some shampoo out and see how it looks. It looks the same throughout. Sugar water, similar to salt water, right? Would be homogeneous. And then a peach pie, or an apple pie, or a cherry pie. Right, the peaches or the apples or the cherries are not evenly distributed throughout the different slices, so this would be heterogeneous. All right, questions on those basic or fundamental, not basic, but fundamental ways in which we differentiate between different types of matter. So to put all this together now at the end, actually we'll put it here in the middle. We have a nice little spot available. We can then redraw our classification scheme, and we can say that matter can be either a pure substance or a mixture. And then each of these has a couple subcategories themselves. Right, so the pure substance can be either an element or a compound. And then the mixture can be either homogeneous or it can be heterogeneous. Right, that's the basic classification scheme you'll see in pretty much any chemistry textbook that you look at in terms of how we describe and differentiate the different types of matter that we're going to encounter on a regular basis or more regular basis from this point onwards, when we start looking at what makes up everything around us and in us. All right, so we can classify matter based on its composition in terms of what it's made up of, according to this classification scheme.